Welcome to physics class. First of all, I would like to discuss question asked in previous video. Question was, Mukti was looking into outer and inner faces of new steel spoon. She found that she could see her clear image in both the faces of the spoon, but in one face the image was erect and in other face the image was inverted. She discussed this with her physics teacher, who explained her clearly the reasons. She got satisfied and was happy to know the new things. First question, which face or side of the spoon forms erect image and why? The outer face, bulging face of the spoon act as a convex mirror. Hence, this face forms erect image. You can see correction pen and its image, erect image in this outer bulging face of spoon. I have taken this convex mirror. Again, we will see the two cases in which image is formed, which is diminished, means small sized image than that of object. I have taken again the correction pen. See, when it is in between infinity and pole, image is formed which is smaller than the actual size of this correction pen. Now I'll move it away from the mirror. Size is diminished, but image is erect. You can see. Okay. Second question, which side of the spoon forms inverted image and why? Inner face of the spoon act as the concave mirror. When spoon is away from the Mukti's face, real and inverted image is formed. Let us see this by using this correction pen. When it is away from the spoon, image formed is inverted. When we bring it closer toward the inner face, you can see image formed is erect between pole and principal focus. When we move it away, then image formed is inverted. Its lid is downward. By using this concave mirror and this screen, again we will show you its inverted image of the front building or house. You'll be able to see, yes, here it is, inverted image of the house, which is here, this house. Is it clear? Sky is here. This is inverted image. Third question, what value do you learn from Mukti? We learn from Mukti that if we observe anything new around us, we should discuss it with our elders and teacher to gain more and more knowledge. Now we are going to start today's topic, but you have to guess the topic. I will not announce it. You have to guess the name of the topic by certain activities. Okay, first of all, we'll start this glass full of water and this spoon. I'll dip it likewise. Observe carefully. What happens? There are two parts of spoon, lower part and upper part. Here one. Now you can see this observation also. There is only single line. Again, there is a gap between part of spoon which is outside water layer, upper layer of the water, and which part is dipped inside the water. What do you observe from this? Activity 2. I'll dip this pencil again, this beaker. What happens? Observe this. For next activity, I have used this laser light, white sheet which is folded, and first of all, see the path of light. I have a mark over there, rectilinear path of light. Okay, Now I'll place a glass slab in the path of light. What is the observation? This is the mark, actual mark, and there is a shift towards the path of light. How is it possible? Light bends? Yes, path of light bends when it passes through this glass slab. What is path of light? From this source to air, then glass material, then again to air, then to screen. Now again we will repeat this activity but with different material. There is a spot or circle on the page where light ray falls from the laser light. Now I'll place this glass full of water here in between the path of light and spot. Again there is difference. Here is the mark and here is the path of light, which is not straight line, straight line, but it is somewhere else. If I change this position here, there is a shift. Now if I place glass here, again you can see path of light is changing. Why it is so? Because it is cylindrical in shape and act as somewhat lens. That's why there is change. You can see light ray passes from air to glass, then water, then again to the glass layer, then to air. Again there is bending in path of light ray when it passes from one media to another. Here are different mediums which are transparent through which light can pass. Air, water, glass, all are transparent medium. For next activity, I am using this honey and this laser light. Now you will be able to see the change in path of light. Are you able to see? There is some bending. Okay. Next example, to the cooking oil, when we pass this laser light. Here you can see the path of light and it will bend because inside the bottle there is air above the level of oil. Light ray this time passing through air, then to oil. See the path? Now if light ray is incident directly from the oil inside the bottle, then see the change in path. Now both of changes you can observe. One, this one, two. Observe this. Now we are performing this activity in the darkness so that path of light will become visible. Again you can observe the change in the path of light. We may understand this bending by using certain mold material, likewise Listerine. Observe the change in path of light. Are you able to observe? Yeah, it is very clear. For clear vision, I am changing the side of this bottle. Again, observe the path of light. It is very clear. Downward and there is change in path. Is it clear? Next material, hand wash. Now observe the path of light from this angle, then this angle. There is change. For next activity, I need white sheet, glass slab, thumb pins, pencil. First of all, I'll fix this white sheet on the drawing board with the help of drawing pins, and then marked the boundary of this glass slab with the help of pencil like this, so that at any time of the activity, if it got displaced, I can arrange it on the same place. Now this is point of incidence. I have made a normal here, which is n dash. Here this point is B, incident light ray. I'll place one pin here and second pin here. There should be gap of 4 to 5 centimeter. This angle is between incident light ray and normal, that is angle of incidence. It is 40 degree here. Angle I equal to 40 degree. I placed 2 pins on this incident light ray. I have placed pin P and Q on the marked place on this incident light. Now, next step in this activity, I have to observe those 2 pins from this side of the glass slab, so that when I place a pin, first pin R, then the 2 pins over there, P and Q, will hide behind this pin, so that all will be in straight line. Now, in the similar pattern, I'll place this S pin in such a way that all the other 3 pins will hide behind this pin. I'll be able to see only the last pin, and all should be straight. We have to arrange them properly. Now is the very important part, means observation part of this activity. Look at the pins, red pins and then green pins. I'll show you through the glass slab. All the pins will be in straight line. Right now you will be able to see 2 green pins over there and the red pins here. All are 4, but I'm in the different direction. But if I move it likewise, now with the observation, you'll be able to see only first pin towards my side, means last red pin. If I move it here, all the pins will be visible, all the 4 pins. Clear? Again I'll show you. Likewise, all 3 pins behind this red pin, 4th pin. I will remove these pins one by one and mark their position with the help of pencil. Now I will match these 2 points R and S with the help of pencil and scale. Likewise. Now this is C point, where the light ray emerges out of the glass slab. Again I have drawn here normal and N dash, and the emergent ray, this is C, D. Then angle between the normal and emergent ray will be the angle of emergence. When we match B point with C point, there is certain bending, change in the path of light toward the normal. This is this ray. BC is known as refracted ray. AB is incident ray. This is normal, and again this is normal at point C. This is emergent ray. I have extended this incident light ray. Likewise, I'll mark here angle of incidence I1, and this is angle I2, because this light ray acts as incident light ray for this phase, and it is emergent ray which comes out of this denser medium, which is glass. Light ray enter from rarer medium, that is air, to glass to air, and here is bending away from light ray. I1 angle is 40 degree. Angle of emergence, angle E, that is 40 degree again between normal and emergent light ray. It means angle I1 is equal to angle E. Okay, this is I1. Now, second part, angle I2 is equal to angle R1. This is angle I2, which is equal to angle R1. Now we will understand the laws of refraction of light here from this diagram. First law, incident ray, refracted ray, and normal at the interface of two transparent media, air and glass here, all lie in the same plane. Second law, the ratio of sine of angle of incidence to that of sine of angle of refraction is constant. Sine I upon sine R equal to constant for the light of a given color for the given pair of media. This law is also known as Snell's law of refraction. This constant value is called refractive index of the second medium with respect to first. Likewise, we have to draw the diagram for this activity, and it is also given in your book. So it is very clear from the discussion of the day or this video that light ray, when enters from one transparent medium to another, it bends. So our topic of the day is refraction. Hence, we can define the refraction of light as the phenomena of bending of light at the interface of two media when it passes from one transparent medium into another transparent medium. Question 1. Draw a ray diagram showing the path of rays of light when it enters with oblique incidence. First, from air into water. Second, from water into air. Second question, draw the ray diagram to show that a 5 rupees coin appears to be raised in a bucket of water. I will discuss these questions in my next video. Till then, think upon their answers, and thank you for watching.